Okay, all, I have 11:33 from my watch, so we're just going to go ahead and get our presentation started. My name is Nicole Deringer from Boundary Systems, and I wanted to welcome you all and thank you for joining us today. And today, our webinar series is actually going to be presented by one of our good partners, International Tech Group, or ITI. Our colleague, Steve Utterdijk, is going to be presenting on advanced tools for geometry repair and downstream model simplification. Before I turn it over to him, I would just like to tell you that by all means, you may ask questions throughout the presentation by using the questions pane as part of the GoToWebinar tool, and he will answer all questions at the very end of the presentation. At this point, I'd like to turn it over to Steve, so go ahead, Steve.
All right, Nicole, thank you. As Nicole mentioned, my name is Steve Utterdijk. I've been with ITI for about 20 years in the role of technical sales and support, mainly focused around the solution I'm going to be talking about today, which is CADfix. Before that, about 5 years in the world of gas turbine engine analysis. Just briefly about International Techne Group. As you can see from the locations, we do have a global presence. Our world headquarters are in Milford, Ohio, just outside of Cincinnati, but we also have offices in the UK, Germany, as well as Tel Aviv, Israel. Different customer initiatives we are focused on are model-based enterprise, product lifecycle management, advanced simulation, digital manufacturing, and across those initiatives, we offer the various solutions of conversion, integration, validation, and migration. We are a private company still with about 120 employees, and we're founded back in 1983. Again, today, the solution I'm going to focus on is our CADfix solution. CADfix is all about minimizing the downstream rework associated with CAD, CAM, and CAE data exchange. And to that, we offer geometry translation with healing and repair. We support all types of native CAD as well as neutral files, depending on what system you're using, what file formats you are trying to exchange, as well as the translation with healing and repair. We also offer a lot of advanced simplification and defeaturing in terms of repurposing your model for downstream analysis. I won't spend too much time on this slide, but this slide is kind of the full product overview. I'll just show the imports here. I won't read all of them, but most importantly on the top line are native interfaces to the Creo format. That's the part and assembly file representations, as well as Creo view, which is a visualization format. And then we also support the Granite format, which is kind of the underlying modeling kernel of Creo. Second line, you can see, is a wide variety of different neutral or modeling kernels that are used to exchange data between various systems. The third line is some specialty analysis systems. We do offer 3 modes of operation, and I'll kind of touch on those during the presentation as well as a demonstration. Comprehensive functionality, repairing, simplifying, and preparing the data for that downstream target system. And then on the export side, again, on the top line, you can see we support the native Creo formats, Creo part files, the Creo view file, as well as the Granite file as well. The second line you can see is just about the same with all these different types of neutral formats and modeling kernels. And then the last line, we have even more tie-ins to specialty analysis systems that we've kind of written over the years as custom one-offs. So why would you use CADfix specifically as a Creo user? First off, the translation and data exchange and visualization as well. So we do support, again, different visualization formats, Creo view being a specific Creo format, but there's other ones as well, like JT, STL. The geometry repair, so if you got a file that's just not a valid solid when you bring it into Creo, we have a lot of tools to address that. I'll be showing a lot of those. Pre-processing for CAE, simplification for IP protection, We also have a different version of CADfix, if you will, that we've launched in the last few years called CADfix PPS, which offers automated simplification for downstream plant process and shipbuilding applications. And then specific Creo user benefits, the ability to translate CAD to and from those different native Creo formats. Specific Creo diagnostics are actually run against the part on export to ensure it's a solid. I'll show that in the demonstration. The ability to exchange faceted models to and from Creo view. So again, if you have an already faceted model from some kind of visualization format, you can exchange back and forth between Creo view using CADfix. Model tree independent simplification and IP protection, as well as the ability to shrink wrap assemblies. So most all of CADfix is kind of geared and first started off by what we call the wizard. This is kind of going to guide you through the complete process, starting with import, repairing the model. Transforming the model is going to then deal with, are you defeaturing it? Are you simplifying it in some way? So that's obviously an optional stage. And then preparing the geometry for the downstream system, and then ultimately exporting that file out to that downstream system. And we found over the years that basically 80 to 100% of geometry problems can be repaired automatically in terms of the wizard. And I'd probably push that closer to upwards of 90 to 95% really in the recent years. So the graphical interface to CADfix really looks like a CAD system. You're going to have powerful visualization of the model and its problems. You've got a wide variety of user tools, including the wizard, the diagnostic-driven repair process, which I'll highlight as well. So if something doesn't repair 100% through the wizard, we run diagnostics against the model, show you those diagnostics, let you deal with the problems, and then a wide variety of diagnostic fixing tools. The problems are highlighted on the screen. You'll get essentially fix methods that you can link to try to fix that problem. So this is kind of a demonstration of that diagnostic-driven model healing. The model essentially is scanned for the problems remaining, what is preventing it from being either a valid part or from being well suited to go to your downstream system. You see the problems, you highlight on the problems. On the bottom are the possible fix methods. You can link to any of those fix methods, and then the problem is fixed. If you run the appropriate tool, the model's then rescanned. And so you kind of get a live update of what are the remaining problems until you don't have any more problems. So in terms of repairing CAD models, obviously the goal here is to generate well-connected solids or shells. You could be dealing with just surface models. You're closing topological gaps, building missing faces, building the solids if they don't exist, repairing bad face definitions, maybe removing unwanted data that's in the file that you have no need for. Maybe it's construction data. You're only dealing with the actual solid model. Resolving integrity issues, as well as validating topological definitions of the geometry. And so that's repairing the model. Repairing the model is geared towards getting a valid topological solid. And then once you then take the target system into consideration, we talk about preparing the CAD model. So this is preparing the geometry, preparing the underlying mathematical definition of the geometry to be as best suited as possible for that downstream system. So there's a wide variety of geometry conditions that could be causing you problems exchanging that data downstream, or maybe meshing in an analysis system or something like that. So these are discontinuous surfaces, badly parameterized surfaces, degenerate surfaces, overly dense or large surfaces, twisted, folded, self-intersecting surfaces, the ability to simplify complex surfaces to primitive forms like cylinders, planes, cones, and the ability to reduce surface complexity with NURBS knot reduction. And then the ability to heal edge and surface deviation. So that really deals with the accuracy of the geometry, and that geometry needs to be accurate to a certain point And that's going to be dependent on what downstream system you're going to. So CADfix kind of has all of those underlying recipes of how to prepare and heal that geometry based on what downstream system you are targeting. Just some other pictorial examples of the type of problems we solve in the prepare. Again, I mentioned twisted, folded, self-intersecting, degenerate surfaces, the ability to simplify surfaces. So in this case, we can see the underlying surface has a cylindrical shape and we turn it into a cylinder. And then bad surface parameterizations, being able to fix those. This is kind of a case study of a particular model. This model, gearbox model that was ultimately headed towards a system called MagnaSoft, which is a casting flow simulation software. And you can see the original model had a huge number of surface problems, self-intersecting surfaces, folded surfaces, twisted surfaces. So those are just some pictorial examples of some of the fixes. And the fixes are automatic. So again, once you see those problems in the list, the link to them really attempts to fix all of the problem surfaces. So if you have 40 self-intersecting surfaces, the fix is going to go through and attempt to fix all 40 of those in one shot. So that's model, repair, healing, and translation. There's also in CADfix the ability to make sure your model is well suited for downstream analysis. So the geometry may be complete, it may be accurate, maybe topologically well connected, but it's much more complex, and you might have a lot of topological complexity in the model that's just not needed. So CADfix gives you the ability to get down to that appropriate level of detail for analysis. So if you look at the two images here, the geometry or the shape of the model is really the same. But the topology on the left side is obviously much more complex, overly complex. You've got a lot of sliver surfaces, just multiple surfaces defining the same geometry. So what we've done from the left-hand side to the right-hand side is obviously a lot of surface joining, maybe some collapsing where appropriate, but basically topologically simplifying the model. So there's topological simplification. There's also feature simplification. There may be just plain features that can be removed based on the level of detail that you need in that analysis model. So we offer a wide variety of defeaturing operations. Collapsing small features. These can be short edges, small or thin faces. Joining small features. Again, this can be chains of edges, groups of small faces. Hole removal. Wide variety of types of holes that we can remove. I'll give some demonstrations of that. Splitting complex entities. So you can be splitting solids, maybe splitting complex faces. Feature removal, the ability to remove protrusions, fillets, bosses, ribs, and chamfers. So some of the particular operations in detail, sliver faces, the ability to join neighboring sliver faces to their large neighbors or to collapse them where appropriate. So again, this is an automated tool, allows you to search the model, look for sliver faces in the model, look for faces next to them that are appropriate to join them up to, and do that automatically. You can also join faces by picking them. So you may have a region in the model that you think can be simplified. Maybe it's a certain area where you don't need as much topological detail, so you can pick any group of faces really and simplify them. You can also use the automated tools to search for appropriate groups of faces in the model and simplify them. The sharp corner fix. This is focused on the types of faces that, again, topologically they're fine, and for the most part, most of the face is fine, except that it tapers down to a very, very thin angle on one side. So this is the type of face that when you go to mesh it, it looks fine for most of it, and then it tapers down to very, very small elements and has to transition to very, very small elements in that corner. And so what we look for are these sharp corners, and we basically merge the edges back up to a certain point, such that the angle that you appropriate in this tool is not, the face never goes below that angle. So the ability to fix those conditions. So fillets, blends, rounds can be removed. Again, for all the tools I'm showing here, there's an automated searching mechanism that can find these type of conditions and attempt to remove them or simplify them on the whole model. You can also override that and pick any type of item you want. So if there's a particular fillet that you want to remove, but you don't want to remove all the fillets in the model, you can automatically, or you can individually select anything you want to operate on. Same thing with chamfers. Again, there's an automated tool that looks for chamfers. Likewise, you can also pick chamfers in the model that you particularly want to remove. So it looks for, in this case, it's looking for a setback angle that the chamfer is defined by finding any chamfer that meets that criteria and removing them. Hole removal. As I mentioned, there's a large variety of types of holes that we can remove. So first off, we can remove holes just in surface models. But this is obviously an example of removing holes in a solid. So holes can be through holes, blind holes, or what we call complex holes of 3 or more openings. And once we start opening it up to that, we're actually looking for cavities inside the part. And then along with the type of hole, there's obviously size filtering. So you may want to focus just on small holes because you don't need those for the analysis, but leave the large holes behind. Size filtering allows you to do that. There's even an operation, as you'll see from the next slide, that allows you to not only find holes, but turn those holes and or cavities into bodies themselves. Okay, so this is obviously important for the CFD world of analysis, where you're modeling the flow inside of a part as opposed to the part itself. So you want to represent essentially the negative space of the CAD model, not the CAD model itself. So we find those cavities with the hole tool, and we turn those holes, or we turn those cavities into solids themselves. So that's an example of this. Imprinting. Imprinting is the ability essentially where you have contacting solids, and again, you're going downstream to analysis, and you want to mesh these solids. These are 2 distinct solids that do contact each other, so you need to establish some kind of contact interface between them. And to do so, you need the nodes and elements of the 2 mesh solids to line up with each other. But the problem is these 2 solids have no topology in common with each other. So what imprinting does is essentially imprints the topology of the 2 bodies onto each other. So where those 2 solids do contact each other, they can remain distinct, separate solids, but they're going to share the same topology. They're going to have the same face definition where they do contact. So when you do mesh the solids, the meshes where those 2 solids contact each other line up exactly, and then you can create the contact regions you need appropriately in the downstream analysis system. The ability to essentially kind of a quote shrink wrap or merge everything together, so we can join coincident bodies. So this is just a demonstration of an assembly with 18 bodies. Those assembly structures exploded, so you remove the assembly tree, the intelligence there. You just kind of turn it into a flat file of multiple solids, and then all of those solids joined up into one solid. So just a kind of an example of IP protection, kind of taking away the detail of a model, and giving maybe the downstream user only what you want them to see. And then I mentioned CADfix PPS in the beginning. So this is a new form or new launch, if you would, of CADfix that gives the users in this industry just the tools they need. They're dealing with very, very large vendor CAD models. They're trying to take those downstream into plan layouts, and they just don't need all the detail that's in these models. So CADfix PPS is specifically focused on removing that type of detail in an automated way. So this has a big application in the power industry, oil and gas, food and beverage, just to name a few. So it deals with the operations of small body removal, removing internal detail, as well as geometry shape simplification. So maybe taking pieces of geometry that are quite complex, but essentially very close to a bounding box or a cylinder, and turning them into that. So in the end of the day, the idea is to reduce the face count by a huge amount so that we can reduce the file size. However, the part looks like it basically should. It sits where it's supposed to. The user can incorporate that into their plant layout and really still have exactly what they need, but get rid of all this detail, get rid of all this file size so that they have a more nimble and more efficient plant layout. And if they can do this on one piece of equipment, and maybe they have 20, 30 more of these types of pieces of equipment across the plant layout, if they can do this on one piece of equipment, they can just multiply that file size savings across the whole plant layout. So I was going to launch into some demonstration of CADfix. So this is CADfix. I'm going to start first by just taking an IGES file, and I want to bring it in. I'm not going to do any transformation or simplification on this file. I just want to translate it out to Creo, and we'll take it out to a native part file. This is a file that does have a couple of issues that, as the wizard settings are currently, won't be fixed. I could actually change the wizard settings a little bit to fix these issues, but it's a good file to kind of introduce the idea of the diagnostic driven process of CADfix. So it runs through the repair. It goes through a stitching mechanism. It basically kind of ramps up the tolerance each time, maxing out at a certain tolerance. At the end, it realizes that it still has poorly connected edges remaining, and it hasn't been able to build a solid. So when I say poorly connected edges, we have kind of a color coding mechanism for the edges that show the face connectivity of each edge. So for a valid solid, we want all the edges in the model to be green, and then all those faces form a closed shell in the solid body. If we have red edges, we essentially have either a gap or a missing face or surface, most likely. So the model is scanned. As you can see, that you get a summary here. It says, okay, we've run the wizard process. We have failed to repair the model based on solids, which is the model setting that I had in the repair wizard. It tells me the reasons for this failure, basically, that we do have these edges of connectivity 1, and we can resolve the model problems in this order. And you have a few options here. You could actually go back and change the repair options. Like I mentioned, if I toggled a few of these, I could actually automatically repair these 2 issues. You could say, I'm not sure how to, fix it, so just continue on with the wizard. In this case, we talk about resolving the first model problem. In this case, it's kind of unique because we actually will control the color of the model problems based on how the order we need you to fix them in. Okay, so unused faces is actually a very important problem because until we build a solid body, all the faces in the model are unused. But we know that we don't want the user to pick on that problem and try to fix it, because there's no way they can fix that until they fix the topological problems in the model. So you'll see once I fix the poorly connected edges, the unused faces will rise to the red level. So we have poorly connected edges. Like I said, this usually represents a gap or a missing face. Again, you have the possible fix methods, which is really where you want to go to. In this case, I see the red edges down here look like a gap. I could choose to stitch them up at a coercive tolerance. I could also recognize that, hey, this is a situation where I would love to be able to control the direction of this collapse, such that the vertex that these 4 faces share is not going to move, the one on the left here. If I choose collapse points, which is the tool I chose, I can control that direction, and I can appropriately collapse the right point to the left point. So I do that fix. You can see again, I mentioned that the problems are rescanned every time you do a fix. We're down to 4 poorly connected edges. In this case, it's certainly much larger than I would call a gap, and I would definitely categorize it as a missing face or surface. So I choose to build faces in this case. It's going to show me the new surface it's created, ask me if that's okay. I can accept or reject it. In this case, I accept it. As I mentioned, unused faces has now risen to that red level. It's the only remaining problem in getting a valid model. And in this case, CADfix also comes back and says, hey, the model is properly connected, basically trying to lead the user back to the wizard saying, hey, do you want to go ahead and build the bodies, continue on with the wizard? In this case, I'll say yes. Okay, if you can see the progress window here, that new solid body is created. It then launches into the prepare for export. So it's now preparing the model for Creo 4, doing the specific operations that are appropriate to preparing the model for Creo, and then exporting the part file. And as I mentioned, it runs some diagnostics, validating that, yeah, we do have one solid body created, and that it checks out. And then obviously within CADfix, I've been showing this model in wireframe, but you can shade the model, rotate the model, lots of different display tools available in CADfix as needed. I'm going to do another model, which in this case, I'm just going to take a step file. I'm going to pass this one through. This one doesn't have any topological issues that are not fixable within the wizard, so the wizard will do the job here 100%. In this case, I'm going to choose to export a Creo view model. So this is a model that maybe I only need for visualization. I don't need the actual geometry anymore. I can tessellate the model, and CADfix will do that within the automated process here. It'll tessellate the model and export it out to the Creo view format. So as you can see, when it comes up, I'll move the progress monitor slightly to the left here so you can see the model in the background. The topological repair is completed. It's said that we do have a valid solid body, nothing necessary to fix. As you can see, it goes into the prepare for export, just like the other one does. So it's running some specific operations on the geometry to make sure it's well suited to be tessellated and then exported to Creo view. And then again, it runs some diagnostics. In this case, not a part file, but a Creo view.ed file is exported. And just real briefly, I have that same model that I processed right here in Creo, opened up as a Creo. It was a Creo view file. You can kind of see the tessellation on the underlying surfaces instead of being real NURBS-based geometry anymore. The file's been tessellated. But again, you may only need the file for visualization purposes, and that might be completely fine and acceptable. So that's the file shaded in CADfix. I'm going to open up another file here that requires a little more hands-on repair. So this is again starts off as I believe it's an IGES file. Definitely has some connectivity issues. Again, there's some wizard settings that can be adjusted. You can adjust the tolerance. You can do things like essentially building faces on loops of poorly connected edges after all the stitching's been done. In this case, I'm not going to change any of those operations. But you can see we still have quite a bit of red edges left here. I'm going to use some different, some of the same techniques as the previous file and some different ones. So again, we can click on the first problem here. And same thing, poorly connected edges in this case are at the red level. unused faces are blue right now because it wants to control the order I do these things in. So I can choose to, this is kind of like an overhanging face. There's a few different fix methods that would get rid of this. Collapsing points, though, is probably the easiest. So when that's a possible fix method, I usually use it. In this case, we can query the geometry up here and see that we just have these two faces here that are separated. Now I could stitch the edges here, although I want to keep that edge on the left-hand side exactly where it is because it defines the edge of the part here. So in this case, I'm going to use a different technique, and I'm going to choose to edit the definition of this face right here. So editing a face allows me to choose the curves that define the face. So I'm going to, I toggle on the remove key there, remove those two edges, and then I place this edge in its definition. I use the same surface that's already there. It's actually already extended to the right place anyway. And so what I've done is redefine that face as appropriate. You can see we have a white edge remaining. That's an unused edge, or in this case, two unused edges. And we can always just kind of clean them up and delete them as needed. So a couple more areas here. Another good candidate here for just sealing that gap up by a simple collapse. Again, doing collapse here because there's definitely an edge here I don't want to move, or a vertex point here that I don't want to change the position of, so I want to control the direction of collapse. And as you can see, as I'm doing each of these, it's updating as necessary, or updating or rescanning the problems and updating the problem count over here. And here's another example of a couple of faces that overlap. This is the one that you can see was just not trimmed back to the curve it's supposed to be trimmed at. It should be trimmed here where these red edges are on the right-hand side, but this face is shot over that boundary. Kind of has the planar square look at the end here. So it's another great chance to use the edit face capability. In this case, I'll use the quick pick tool. We have a variety of quick pick tools on the right-hand side here that allow the user to very quick access to tools maybe they use very often. You can actually customize this toolbar. We do set the toolbar up with kind of a default of tools that are the most commonly accessed quickly, but you can customize that if you want. So in this case, I'm adding edges that I want in the definition of the face, and then removing the others. Quick hit of that button assumes I'm going to use the same surface. And again, we have a few leftover edges that we can clean up. And now we're down to just one remaining area of red edges. In this case, you can see again, missing face or surface on the model here. So I'll use the tool that I'll go ahead and do that. And then again, it comes back, says, hey, we're all green now. We're properly connected. You want to continue on with the wizard? I'm going to say no here because all I would do is go ahead and run it through the wizard. We've seen that before, so I'm going to stop at the stage here. I'll just manually build the body. So it takes all those unused faces, turns it into a body. And again, I'll shade it here just so we can see it. And I'm going to go off to a model that I'm going to do some specific defeaturing on. A little IP protection even. So this is a model that I want to go ahead and I'm going to import it and repair it. But I want the process to stop there because I want to go ahead and simplify it and do some defeaturing on the model. So again, the repair wizard goes through. You can see this model came in all green anyway. It happens to be an assembly. So you can see as I hover over the assembly, the different components that are in there. So I'm going to show some different simplification options. In this case, I'm going to, first I'll shade it just so we can kind of get a feel for the whole thing so we can see. We kind of got one main part here. We have a lid on top of there. We have a lot of accessory parts here. I'm going to kind of focus this on weeding this down to just that main part. We have the assembly tree here, as you can see. One thing we can do from an assembly is we have a few searching options. One that's kind of handy is the ability to search by label. So you can see in the component names, there are some components that just kind of scream out that, hey, these are small components that you can probably get rid of. So just by searching on the wildcard and then the name screw and then wildcard, basically going to find any component in the assembly tree that has that text string in there. Automatically select all of them, and then I can just delete them right there. Rivet is obviously another good candidate here. I'm going to find those. I think those occur on the other side of the model, so they're not visible at that point. So I've stripped away those small components. Another operation I'd highlight here is the ability to look for internal features. So I'm going to look for any bodies that are internal to this model. In this case, it finds 6 bodies. They're actually inside. I should have, let me just go to wireframe mode here so we can actually see what it finds. I'll do the find again here. So it finds those bodies that are completely internal. I can remove them automatically. I'm going to go back to the assembly tree here. And I talked about flattening or exploding the assembly structure, so I'm going to do that. So basically now I just have a list. I have essentially a single part file now with multiple bodies in it. And again, I want to weed this down to that last, it's the main body. So I'm going to pick it, and then we have the ability essentially just to delete. I don't want to delete it, but in this case, I want to delete everything that I haven't selected. So I've kind of taken this assembly that it started as, first off, gotten rid of the assembly structure and taken it down to that single body. So now we'll look at some more part-based simplification and defeaturing operations that we can do. So holes. So removing holes in bodies. Again, I talked about the types of holes we can look for: blind holes, through holes, those complex holes. Also, one thing I didn't mention about hole search is you can also control the shape of the hole. So you may think about classic circular holes. You can also open that up to any type of geometry that you want. So it can be any geometry cross-section that goes into or through a part. And then we have size filtering. Obviously, 2 different ways of doing that: just the pure exit size of the hole coming out of the part, or you can look for more like a 3D bounding box around the hole, the entire hole feature. So I'm going to look for all the holes that meet this criteria. See, these are circular holes only. We do have a size filter on those. We're looking for through holes or blind holes. You can see all the different holes it finds. They're highlighted on the screen. Get rid of all those. Then talk about a little bit of, we have the ability to remove fillets, remove chamfers. We essentially have a very handy quick pick tool that's called remove features. So this essentially operates on any selection of faces that you have active. So I get into what we call our selection tool. And I don't want to pick faces one by one, but what I want to do is enable a search mechanism we call Smart Select. So this is essentially looking for fillets and rounds. And by clicking on a radiused edge within that fillet or round, the whole fillet or round should be selected. So you can see I select that. And then I'm going to hit the quick pick tool here. our quick pick tools are also designed such that if you're happy with the settings in it, you can click this off and you won't even see a box come up anymore. It will just automatically remove the feature. So you can see the round's been removed off of there, back to a hard edge. A few different areas it can do that kind of thing there. The tops of those features being selected. As you can see, I don't have to limit my selection to just one area. As long as they're separate chains of fillets or rounds, you can operate on them. And then not only fillets or rounds, but remove features, like I said, will really operate on any finite select set of faces you might have selected. And so what I'm going to do here is kind of pick some faces here that define these little this little keyhole feature here, and then this rib that kind of goes through this other rib. Again, removing these, just reducing some of the complexity of the model, maybe getting rid of some things that either I don't need in the analysis or some things that I think may cause some problems in the analysis. So I've gotten the model down to here. I also mentioned filling models or looking for cavities. So kind of two ways I could do that. I'll go back to the hole feature and finding of the holes. In this case, I'm going to go ahead and click on complex holes. I need to consider any type of geometry cross section. I'm not going to put any kind of size filtering on it. And it's going to come back and you can see that it finds this one hole that's kind of a rectangular hole on the side here, and then it finds the entire hole that basically is the whole interior cavity of this part. And by doing this, you know, I'm really kind of simplifying the model, taking again, some IP simplification here, and filling in this whole thing to be solid. So we don't have any interior to this casing anymore at all. Another option I mentioned, turning those interior bodies into solids themselves. We do have an undo and a redo capability in CADfix that actually goes backwards and forwards 10 times if needed. I'm just going to go back one operation in this case. So I'm going to go to the tool that it's essentially finding the same things. It's finding these interior cavities. But in this case, I'm going to go ahead and turn those interior cavities into bodies themselves. Okay. So what I've essentially done is got rid of the original part, and now I have two separate solids. Maybe I don't want that one. I'll just quickly delete it. And I've got this, which is a representation of the interior of that casing. So again, important for downstream CFD applications to model the negative space or the interior of a part. I'm going to go ahead and pause here and pop back to the presentation and open it up now if there's any questions from the audience. And I don't see any questions, but if you do have any questions, go ahead and enter them in the chat window. All right, I guess I don't see any questions at this point. So contact information for ITI and Boundary Systems is there. If you do have any questions further on that you do think of, or anything about this presentation you'd like to ask, or any more information about CADfix or any of the other ITI solutions that we do have, the contact information is there, and you can definitely contact us. So, oh, it's here. I got one question. The CADfix module is a separate piece of software. So the question is this a separate module you have to buy? The CADfix software is a separate piece of software. It's a multi-CAD translation and healing tool, so it's not necessarily Creo specific, but it certainly will translate, heal, and repair models either to Creo or from Creo. So we support both sides of the equation. We can import Creo models as well as export them, but we also support a wide variety of other formats as well as neutral formats. So it's kind of a multi-CAD solution, not only CAD, but again, also downstream analysis. So this is a separate piece of software. And if you are interested in talking about that or looking into it further, please do contact ITI, and we'll be happy to answer those questions or show you more of CADfix, and we can also show you CADfix on your own data. So if you have problem geometry that you're struggling with in one way or the other, whether it's translation or trying to simplify something, we can demonstrate CADfix on your data. Okay, is there any other questions? All right, well, I guess, Nicole, I guess we will wrap it up here.
Okay, sounds great. Thank you all for attending today's webinar, and feel free to check out our schedule to see what upcoming topics may interest you. And if you have any questions, like Steve said, contact ITI or Boundary Systems, and we'd be happy to help. Have a great day.